Hi guys and welcome back. Today we are going to take a look at this military unit. I bought that thing from eBay, UK. On the front there is a rotating mirror assembly. As you can see, there is no marking at all. I don't know the manufacturer, I don't know anything regarding this unit. Oh, okay, so look at that. There is here a connector, one diode, two trimmers. It's a kind of sensor. Okay, it is written here. Dew point sensor. There is here a circular connector. And here there is something, I don't know if it's an adjustment of something. And here it seems that we have two pressure ports. The thing is very mysterious. So let's start by removing the front panel. Okay, so that's interesting. We have here a head amplifier, a thermal imaging. And here we have the scanning unit, thermal imaging, and a TICM scanner head. And we have a motor drive electronics. Quite a complex unit. The head seems to be this device here because it is connected to the head amplifier. And it seems that this thing is cooled. Yeah, so we can see here there is something called adapter cryogenic. Yeah, so this seems to be an adjustment of the cooling of the head. We have probably here an input of gas, that the input is connected to the device and the output here is fed to the head. So I think that the head is cooled at a very low temperature. A very interesting device. Oh, this thing is spotted. Look at that. We have here a military construction for sure. You can see the silicone potting here. I don't know what we have below this thing here. It's maybe an IC. It's maybe a kind of hybrid circuit. Okay, we can see the date code of the parts 84. So this thing was manufactured in the 80s. Here you can see the holders there for the resistors which are vertically mounted. Now we have here two LF412, this is a dual op-amp. But of course the reverse engineering of something like that is more than complicated, almost impossible. So I think that we have a hybrid circuit below this protective thing here. This is effectively a hybrid circuit, that code 85. We have here the head amplifier. There is a similar construction. It's a flat flex PCB construction. There is a strange part here. It's a moisture absorber. We have here the cryogenic adapter supply L1A1. On the top we have the detector lens mount straight. The thing was manufactured by Hank Taylor Hobson. We have here the sensor. There is the part number. Nice logo. And here we have an optical assembly. A very nice unit. We can see the rotating mirror here. You can see that the motor is balanced here. You can see several little holes, and we can see the motor here. It is difficult to see. Now there is here a transducer RT903. There is a torque motor. There is maybe a control loop. We can see 3 mirrors. One here, the second one, and the last one here. We have here 2 optical sensors. They are identical. And we have here a mirror which can be orientated by the torque motor. This permits to have a scan probably. We have here the optics and also a filter. I didn't find anything regarding this sensor. So this device is a line scan camera. There are 2 axes. So the first axis corresponds to this polygon mirror here. And the second axis is this mirror which is linked to the torque motor. There is a servo control for the position of this mirror. What we can do is to place a laser beam instead of the sensor. Okay, so here I am moving the polygon mirror. And I will try to rotate the mirror attached to the torque motor. It will be more difficult, and normally the spot should move on the x-axis here. Yeah. It is difficult to move because there is a spring, and I don't want to destroy that thing. We have here a beautiful optical mechanical assembly. This thing should cost a fortune to design. So here we have the board which permits obviously the servo control of the mirror. There is here a sensor which is maybe an LVDT sensor and the torqueur. I suspect that these 2 optical sensors permit to detect the start of the scan. I have connected this unit to a power supply, plus 5 volts, plus and minus 12 volts, and plus 28 volts. So let's turn on the power supply. There is a current higher than 400 milliamps on the plus 12 volts rail. Actually, I have an issue with the positive power supply, not the negative one. And I have disconnected everything except the motor control here. I have found a dead tantalum capacitor on that board, which is this one here. There is a resistance of 2 ohms approximately. Okay, so I have changed the tantalum capacitor. Let's turn on the power supplies for the second time. Plus and minus 12 and plus 28 volts. You can see this thing works again. That's all for today. Thank you for watching and see you next time for another video. Bye bye.